In today's lesson, we're going to learn about the trigonometric ratios sine, cosine, and tangent, and we're going to learn how to find missing sides in a right triangle. Introduction to trig. When studying right triangles, early mathematicians discovered whenever the ratio of the shorter leg's length to the longer leg's length was close to a specific function, the angle opposite the shorter leg was close to a specific measure. They found this and its converse true for all similar right triangles. This idea is the beginning of trigonometry. We will explore today the trigonometric ratio relationships and use this information to find missing sides in a right triangle. Here's the big idea of trigonometry. In a right triangle, the sine, abbreviated SIN, cosine, abbreviated COS, and tangent, abbreviated tan, of an angle is equal to particular ratios defined below. So the sine of an angle, here's our angle A. The sine of any angle is equal to the opposite, which is right here, divided by the hypotenuse. This called SO in the famous ratio SOHCAHTOA. The tangent, we won't do tangent next, we'll do cosine. The cosine, here's the cosine of angle A, still angle A, is equal to the adjacent divided by the hypotenuse. Now the adjacent is the side next to the angle that's not the hypotenuse. So you can see that this side is next to the angle and this side is next to the angle, but this is the hypotenuse because it's opposite the right angle, and the adjacent is the one next to the angle. And then the tangent is opposite, so once again, here's our angle, and this is opposite the angle, divided by the adjacent. And the adjacent is the one next to the hypotenuse that's not the angle. So cosine, we say ca, and tangent, we say toa. So sine, opposite over hypotenuse, cosine, adjacent divided by hypotenuse, and tangent, opposite divided by adjacent. Now if you change the angle, so now we're going to look at angle B, okay? Now if this is angle B, the side opposite is side B, so this is our opposite. The hypotenuse is always opposite the right angles. So here's our hypotenuse, and here's the adjacent. Because the adjacent is the side next to the angle that's not the hypotenuse. So sine, in this case, is always opposite over hypotenuse, so it would be little b divided by the hypotenuse, which is little c. And cosine is adjacent, so here's our adjacent, divided by the hypotenuse. So cosine would be a divided by c. And tangent, there's our angle again. Tangent is always opposite divided by adjacent. So our opposite is b, and our adjacent is a. So tangent would be b divided by a. These ratios are true for any right triangle. Now the real question is, what does this mean and how can we use it? The most basic 30, 60, 90 triangle is below. Here it is. Use this triangle to see the trigonometric ratios in action. Before we do anything, we must put our calculators in degree mode. So here's our calculator. So this is an example of your guys' calculator. Now you need to press the mode button. There's the mode button. And then you need to arrow down to, you've got radian and degree. You need to go over to degree, and you need to hit enter. And when you hit enter, degree will be highlighted. If you've done it correctly, degree is highlighted. Now we're going to actually use our calculator and enter in the sine of 30. Now if you look at the picture, here's our 30 degrees, and we know that the sine is equal to the opposite over the hypotenuse. This is our opposite. This is our hypotenuse. Because remember, angle A, in this case it's 30 degrees. So let's use our calculator to see the sine of 30 degrees is 1/2. So when we type that into our calculator, let's go back to the calculator, we hit the sine of 30 degrees equals 0.5. Okay, that ratio is true for any triangle when you do the sine of 30 degrees. Now, the cosine of 30 degrees, once again, remember the cosine is the adjacent divided by adjacent, ADJ, divided by the hypotenuse. So the adjacent in this case is root 3, and the hypotenuse is 2. So we're going to look at our calculator again, and we're going to first do root 3 divided by, here's root 3 divided by 2. So we can see what the ratio would be as a decimal. And then we hit cosine of 30. We get the same thing. So you can see why this is important. Now we're going to see how we can use this to find missing angles and sides. So as we just saw, that's approximately equal to 0.866. You can do the same for tangent. We're not going to do that right now. Okay, first example. Find the sine, cosine, and tangent of angles D and F in the triangle below. So we're going to start with angle D. So we're going to take the sine of D, the cosine of D, and the tangent of D. Now, in terms of D, the opposite is 12, the hypotenuse is 15, and the adjacent, remember the adjacent is the side next to the angle that's not the hypotenuse. So this problem is just asking us for the actual ratios. So the opposite to D is 12, so the sine of D is 12 divided by the hypotenuse, which is 15. When we reduce 12 divided by 15, we get 4 over 5. Now the cosine of D is the adjacent divided by the hypotenuse. So the cosine of D is 9 divided by 15, which reduces to 3 over 5. And tangent is opposite divided by hypotenuse. So the tangent is 12 divided by 9, or 4 over 3. The next question asks us to do the same thing with F. So we want the sine of F, the cosine of F, and the tangent of F. However, we have a new angle. So since we have a new angle, we have a new opposite. So this is now our opposite. Our hypotenuse doesn't change, but our adjacent is now what used to be our opposite, because it's all related to the angle. So the sine is going to be 9 over 15, which reduces to 3f, the sine of f. The cosine of f is the adjacent, which is 12 divided by the hypotenuse. So 12 over 15, or 4/5. And the tangent of f is opposite, which is 9, over adjacent, which is 12. So 9 over 12, or 3/4. It all depends on what the angle is, and whatever the angle is determines what our opposite and adjacent is. The hypotenuse is always opposite the right angle, so that does not change in any right triangle. This next problem gives us an isosceles triangle and asks us to find the sine of C, cosine of C, and the tangent of C. Well, the problem we have right now is we have no right triangle. So we need to create a right triangle. Well, we know with an isosceles triangle, if you drop an altitude, that's a median and an altitude, and so it bisects it. So that means this side is 5 and this side is 5. Now we can find the height, we'll call that x, using our Pythagorean theorem. 5 squared plus x squared equals 13 squared. Now here's the thing. This is a Pythagorean triple. So if you know your triples, you can immediately say that x is 12. If you don't know your triples, then you have to actually do the math. 12 plus x squared equals 169, x squared equals 144, x equals plus or minus 12, since it's positive, x equals 12. So now we have our right triangle. So let me draw our right triangle. We have this is 5, this is 12, and this is 13. This is A, this is unknown. We can call it whatever we want. We'll call it M. And then this is C. We needed to do this because it asks for the sine of C and the cosine of C and the tangent of C, and we needed a right triangle. So there is C. So this is the opposite, this is the adjacent, and this is the hypotenuse. So the sine of C is opposite over hypotenuse, so 12 over 13. The cosine of C is adjacent over hypotenuse, so 5 over 13, and the tangent of C is opposite over adjacent, which is 12 over 5. The last problems used the triangles to find the ratios. Well, now we're going to use the triangles to find missing sides. So this is the angle that we're given. We're given 40, and our opposite is h, our adjacent is 50, and our hypotenuse is x. Now we need to find h and x. Well, the first thing I'm going to use is I'm going to use cosine. The reason I chose cosine is cosine uses the adjacent and the hypotenuse. One has a variable and one has something that we know. So the cosine of 40 degrees is 50 over x. Now this is an equation that we can solve. I'm going to put cosine 40 over 1 and I'm going to cross multiply. So I have x times cosine of 40. This is just a number that my calculator would do, equals 50 times 1. So cosine 40 times x equals 50. Now I can divide by cosine 40, divide by cosine 40 degrees, so x equals 50 divided by cosine of 40 degrees. Now I can use my calculator to find the actual length. So I'm going to type in 50 divided by cosine 40. Now since my calculator was in degrees, this is going to give me the correct answer. So the correct answer is 65.3. So the length of x, or hypotenuse, is approximately 65.3. Now I'm going to use the angle, still the 40 degrees angle, and I'm going to look for my opposite. Now once again, I'd like to use the adjacent side because that's the one that I didn't have to approximate for. So the trig ratio that uses opposite and adjacent is tangent. So I'm going to set up the equation tangent of 40 degrees equals h divided by 50, because h is my opposite and 50 is my hypotenuse. Once again, I can cross multiply. So I have 50 times tangent of 40, so 50 times tangent of 40 degrees. Now remember, tangent of 40 degrees is just a number. So now I'm going to put that into my calculator. So to put this into my calculator, I'm going to do 50 times tangent of 40 degrees. Now remember, my calculator is in degree mode, so this is going to be the tangent of 40 degrees. So that ends up being 41.95, or we can round that up to approximately 42.0. Now you can use what you just learned to complete the try on your own problems. The answers are up here, so complete the try on your own and then you can check your answer. Pause the video, and in a second all the answers will be revealed in the video. Now you can check your answers and the work shown using the video. Here we have tangent z of 12 over 35. You can look at all the answers. A couple things to note. Remember, your calculator must be in degree mode. Do not round. Like when I type into my calculator, I actually type in 17 sine of 16 degrees, and then that's my x value. So don't approximate sine of 16. Wait until the very end to type it into your calculator. Here's all the answers with all the problems worked out. If you have any questions, they'll be answered in next class, as well as you'll do a lot of practice problems in your groups. Thanks. Have a great day.